Unfortunately, converting from decimal rather than converting among binary, octal, and hex, or converting binary, octal, and hex to decimal is a little bit trickier. There's no shortcut here. I will show you two methods though, one that is a little bit of a shortcut compared to the first one. The question we need to ask when we convert 377 from decimal to binary is, how many groups of 2 can we remove from 377? Why groups of 2? Because binary is base 2. How do we answer that question? We ask it using mathematical notation. 377 divided by 2 is 188.5. In other words, there are 188 groups of 2 that we can remove from 377. When we do that, when we take 377 and we remove the complete groups of 2, all 188 of them, we have a remainder of 1. All right, now we're left with 188. When we take 188, we ask how many groups of 2 can be removed from that. In other words, what is 188 divided by 2? 188 divided by 2 is 94. In other words, when we take 188 and we remove all 94 groups of 2, we're left with a remainder of 0. And now we're left with 94. 94, or rather from 94, we can remove 47 groups of 2. And when we take 94 and remove 47 groups of 2, we again have no remainder. And we're left with 47. 47 divided by 2 is 23.5. In other words, we can remove 23 groups of 2 from 47. And when we do that, we'll have 1 left over. We show this by saying we'll take 47 and remove the 23 groups of 2. We find that equal to 1. In other words, we'll have a remainder of 1. Now we're left with 23. When we take 23 and divide it by 2, we get 11.5. In other words, when we take 23, we can remove 11 groups of 2, and we'll be left with a remainder of 1. Now we're down to 11. Once we're down to 11, we ask how many groups of 2 can we remove? In other words, what is 11 divided by 2? Well, it's 5.5, which means that from 11, we can remove 5 groups of 2, and we'll have a remainder of 1. Then we're left with 5. 5 divided by 2 is 2.5. So if we have 5, we can remove 2 groups of 2 from it, and we'll have 1 left over. We're getting there. We're left with 2. How many groups of 2 can we remove from 2? Not surprisingly, we can remove 1 group of 2. So when we take our 2 and remove that 1 group of 2, we have no remainder left. Now we have 1. All right, now we're down to a number that's less than the base we're converting to. And so we're done. What have we accomplished? What we now need to look at is the remainders. Starting with the point where we stopped, we have a 1, and then a remainder of 0, a remainder of 1, a remainder of 1, a remainder of 1, a remainder of 1, a remainder of 0, a remainder of 0, and a remainder of 1. So what is the binary number? Again, we started at this 1. It is 1, 0, 1, 1, 1, 1, 0, 0, 1. So 377 in base 10 has this equivalent binary value. Let's take a look at the same number, and I'll show you the shortcut that I use. Again, we're converting 377 to binary. which means we're asking the question, how many groups of 2 can I remove sequentially from this number? Well, 377 divided by 2 gives me 188 with a remainder of 1. So I'm asking the same question, I'm doing the same mathematics, it's just a nice tidy way of writing down the answer to those questions. Now I'm left with 188. How many groups of 2? In other words, 108 divided by 2 is what? It's 94, with no remainder. 94 divided by 2 is 47, again with a remainder of 0. 47 divided by 2 is 23, and this time we have a remainder of 1. 23 divided by 2 is 11, also with a remainder of 1. 11 divided by 2 is 5, with a remainder of 1. 5 divided by 2 is 2, with a remainder of 1. 2 divided by 2 is 1, with a remainder of 0. And now that we've landed at 1, a number smaller than the base we're converting to, in this case, a number less than 2, we stop. So our binary number is 101111001, just as it was before. We're using the same strategy, but we're using a bit of a shorthand to keep track of what we're doing. So we can use the same method when we're starting in decimal to convert to any other base. The questions that we ask are fundamentally the same. But since we're converting to octal this time, I'm not interested in how many groups of 2 I can remove from the original decimal value. I'm interested in how many groups of 8 I can remove. Our decimal number is 3,478. My question is, how many groups of 8 fit into 3,478? The answer is 434.75. So 434 with a little bit left over. So when I take 3,478 and I subtract my 434 groups of 8, how much do I have left over? I have 6 left over. 434 now that we've sorted out what the leftovers would be, we're just going to take the whole number. Has how many groups of 8? It has 54 groups of 8 with some left over. When we take 434 and we remove the 54 groups of 8, we have a remainder of 2. We have 2 left over. Let's take 54, remove groups of 8, leaving us with 6.75. In other words, if I have 54, I can remove 6 groups of 8. That leaves me with a remainder of 6. Now I've got 6 left. But wait, 6 is less than the base we're converting to. 6 is less than 8, so we stop here. What is our number in octal? 6, 6, 2, 6. So the decimal number 3,478 is equivalent to the octal number 6,626. I caught myself there. This isn't 6,000. This is not the 1,000 place value. This is a number in octal. I'm going to do the same conversion from 3,478 to its equivalent in octal, and I'll use the same shortcut notation that I used when converting to binary. Again, I'm asking the question, in 3,478, how many groups of 8 do I have? So I'm going to divide by 8. Dividing by 8 gives me 434. When I remove my 434 groups of 8, what do I have left over? I I have a remainder of 6. 434 divided by 8 is 54. When I remove my 54 groups of 8 from 434, I have a remainder of 2. 54 divided by 8 is 6. When I remove 6 groups of 8 from 54, I have a remainder of 6. And now that I'm at 6, I'm done. 6 is a value less than the base I'm converting to, which in this case is 8 for octal. So I've finished. I have to make sure to include this 6 as part of my number in octal. So once again, I get 6, 6, 2, 6 as my octal value. I'm going to leave this as practice for you, but let's talk about strategy. Here we're being given a binary number and asked to convert it to octal, decimal, and hexadecimal. Which ones are easiest? Well, if I start with a binary number, I can group my digits by 3 and easily convert that number to octal. If, on the other hand, I take the bits, the binary place values, and put them in groups of 4, that allows me to easily convert to hexadecimal. How do we take any value and convert to decimal? We read each digit in its place value. So that would be my final step. In the second question, we're starting with an octal value. The easiest one I can think of here is to take my value in octal and expand each digit, the 4, the 2, and the 5, into its 3-bit equivalent in binary. Then once I have an answer in binary, well, I can regroup the bits in groups of 4 to convert that to hexadecimal. While I can convert from octal directly to hexadecimal using the shortcut I showed you previously, it's a little bit trickier to use that shortcut, or rather to use that technique, if we're not starting in decimal. Generally, the easiest way to convert between octal and hexadecimal is to first convert to binary. Finally, how will I convert octal 425 to its decimal equivalent? Once again, I'm going to read into decimal. I'm going to take each digit of the octal number, read it in its place value, and that will give me the decimal equivalent. The third value is probably the trickiest, or the third question here. If I'm starting in decimal, there just isn't an easy way to convert to the other number systems. However, it's a pretty small decimal number, so I'm going to choose to convert it first to binary. I'm going to use the technique that we just covered, dividing by 2 iteratively, in order to come up with the equivalent binary value. And once I have my number in binary, groupings of 3 will give me octal, groupings of 4 will give me hexadecimal. You can, of course, choose to take your decimal value and convert directly to octal and directly to hexadecimal using the technique we just covered. And then finally, if we're starting in hexadecimal, I think the easiest way here is just to convert it to explode each digit into its 4-bit binary equivalent, to convert it to binary. Once my number's in binary, I simply regroup the digits in groups of 3, and that allows me to convert it to octal. And finally, to convert to decimal, I'm probably going to start directly with the hex number, E4, and read each digit in its place value into decimal. Try that out, and you can refer to the slides for the final answer.